Hello and welcome to our second OpenHBI tutorial video. This time we want to calculate how long does it take for 18 megabytes to be transferred from host D to host C. And as we can see in our drawing, the packets will use this way to get there. But how long does it take? And how is it to be done? So our plan is to transmit 18 megabytes from D to C via packet switching. And we have several conditions that we have to agree on. So we want to define that the maximum packet size is 252 bytes per packet, including a packet header of 16 bytes, which means the payload, so the actual data that has to be transferred, is 236 bytes. And we want to make this example a little bit easier, and we defined that there is an ideal environment, so there is no other traffic, there is no processing time at the router for receiving the packet and resending it to the next hop. We will have no packet loss and let every packet have the same size. So even the last packet, which probably might not be a full packet, but we will come to that later. So first of all, we have to find out how many packets are needed. These 18 bytes of data we have to transfer are 18 million bytes, which is 104 million bits. 144 million bits, sorry. Each packet with a header has 252 bytes, which is 2016 bits. A packet without headers, only the payload, the data we want to transfer, is 1888 bits. So if we calculate how many packets are needed for 144 megabit per 1888 bit per packet, then we get something like 76,271 point something packets. But as I mentioned, we don't want to have a smaller packet as the last packet, so we just round it up to 76,272 packets. And in reality, there are no 0.5 packets, so of course this would be a full packet with a header and maybe a smaller amount of payload. But as I said, we want to make it a bit easier in this example, so there are only full packets of 1016 bits size. So in order to find out how long does it take for all of the packets, we first calculate the time needed for one packet for the complete route, so each hop. So we have to calculate how long does it take for the packet to get from host D to router 4, from router 4 to router 3, to router 1 to router 2, and finally to host C. So this can be done as follows. We have these 2016 bits transferred via a 64,000 bits per second connection. So if we divide this, we get something like 0.0315 seconds for this one packet to get from host D to router 4. With the next hops, we do exactly the same, just with the correct numbers. So from router 4 to router 3, we have a 2 megabit per second connection. So this leads to something like 0.001 seconds needed for this hop between router 3 and router 1, and between between router 3 and router 1 we have 155 megabits per second. This leads to a duration of 0.00001 seconds roundabout. This is not the exact value. So the connection speed between router 1 and router 2 is exactly the same. So we just can take the same value. And finally, we have to calculate the transfer time between router 2 and host C, which is a very slow connection. It has only 13.3 kilobits per second, and that leads to a transfer time of round about 0.1516 seconds. So we calculated the transfer times for each hop for one packet, for the first packet of all of these packets to be transferred. So we have 0.0315 seconds and so on. So when we add the time needed for the first packet to get from hop to hop and add all the times we just calculated, we get something like 0.18412 seconds needed for the first packet for the whole route. And now we need the time all the other packets will need, but here we can make it a little bit easier because it's sufficient if we just calculate it for the last hop, because the last hop is this really slow connection between router 2 and host C, which had only 13.3 kilobits per second, and this is somehow the bottleneck of the whole connection between host D and host C. And this makes it a little bit easier, so we just calculate the time needed for the last hop, and the last hop, as we can see here, has a transfer time for one packet of 0.1516 seconds. So multiplied by 76,271 packets, we get 11,562.68 something seconds. So the total duration is the sum of the time needed for the first packet in order to be transferred for the whole connection, plus the time needed for all of the other packets for the last hop, which leads to a result of round about 11,562.87 seconds. So this was kind of theoretical, and I hope we didn't confuse you at all. So we want to encourage you to just try it yourselves. For example, calculate the transmission time of 10 megabytes to get from host A to host D, which is this route, or the transmission time of 15 megabytes to be transferred from host B to host A. And we want to encourage you to share your findings to the other learners in the OpenHPI forum and compare your results. And we from the teaching team, we will also check in and check your results.